Good afternoon and welcome back to the workbench. I have here today a power supply here, as you can probably tell by looking at the front of it. It's a Dick Smith branded D-3800. There's Dick Smith down there, but you probably can't see because the negative terminal is in the way, but if I lift it up you can see it there. This is a adjustable 3 to 15 volts or so power supply that can do up to 30 amps peak. That's not continuous. I think the continuous rating realistically is probably about 10 amps or something. Because of the cooling, I think mostly it's not optimized as well as it could be. But this power supply here is not too bad. I bought this because I don't have a power supply like this already. I do have a fixed 13.8 volt supply that can do 20 amps but is not variable. This one has a variable voltage adjustment. So for example, if you're doing like automotive stuff and you're testing a piece of equipment like a car stereo or car amplifier or something, that can be run from anywhere between 12 to 14.4 volts. It should operate over that voltage range. It might work perfectly fine at 13.8, but it might fail at a lower voltage or a higher voltage. So being able to adjust the voltage is nice, to see if the thing actually fully works across the expected voltage range. Or you could just use this as a general adjustable power supply with a decently high current output. Although of course the rating curve for this, is there a piece of fluff floating around in front of my camera? Obviously the lower the voltage, the less current you can get out of it, because the more power is going to be dissipated by the transistors in here, and like I said, I don't think the cooling is that well optimized, to be honest. The design of this is actually from 1999, I believe, or at least that's what the schematic says. And the keen-eyed among you will probably have noticed that this is not a Dick Smith brand power supply. It just has their label on it. The original manufacturer of this is Manson. It's been rebranded about a dozen times for different markets. This one just happens to be Dick Smith branded. Now the first problem I had with it is that it had no knob for the voltage adjustment. I actually 3D printed my own. It's not perfect, but it works. Obviously it's not going to do anything, it's not plugged in. And that brings us around to the reason why this is on the workbench is because I need to modify this to actually make it even usable and to power up at all. Because the previous owner has done some messing around with it. It specifically has added this extra cabling which bypasses the mains input, well, not bypasses it, but routes it through this, and I think this is meant to have been plugged into some kind of remote switch or something so that the thing could be powered up remotely. We've got ground on the green, and then active comes in, live, active, whatever comes in on this, and it's supposed to come back through that, but obviously because these not connected, it's not going to power up if I just plug it in straight away. So I have to take this wiring out and undo it and put the internal wiring back together the way it should be and get rid of this because I don't need it. This was sold as working, but I don't know for sure if that's true, and considering that the person I bought it off, to be quite honest, was actually an absolute creep, I'm not really sure whether to believe them or not. There are some signs of inadequate workmanship on this. For example, the case screws, half of them are missing, of course, but of course one of them was replaced with a big giant wood screw that has stripped out the hole. So yeah, I guess the next thing is just to have a look inside, and I've obviously had a look inside already. It's not as nice as I would have liked. It's not as nice as the front panel would seem to suggest. The front panel is nice and clean and pretty good. Aside from the missing knob, there was nothing a big deal about it. And the case, doesn't look too bad for something that could theoretically be 26 years old. But if we take the case off, we start to see where it's not as nice as it could be. So we do have a decent amount of rust in here. As you can see, not a huge amount, obviously, nothing terrible, but it's not great either. The transformer core has got some surface rust on it, and the bottom of the case is not great either. Yeah, so I might want to try and scrape some of that off and put some rust converter or something on it. Also the fan grill obviously is pretty horrible. I don't see a date code on this. There's a serial number, but I wouldn't know how to decode that. Lovely, they've riveted this on. So they've riveted the fan and the grill on, which looks really nasty. But again, that should be able to clean up and like repaint. But yeah, I probably will need to do that because the fan doesn't seem to be in great condition. It does spin, but it doesn't spin particularly freely. I don't know how well you can see that on camera, but yeah, it doesn't spin as freely as it could. It sort of stops quite abruptly and sort of, yeah, just doesn't look so great. So that needs to probably be replaced. I imagine it still works, but it might be quite noisy or ready to wear out anyway. And then we have other things with this. Let's see. So we have some modifications. We also have this relay here and like a sort of delay circuit, I believe. There's a capacitor under there and a resistor and a diode. I think what the person has done is put like a kind of a startup delay switch on the output, so that the idea being that it won't output voltage until the circuitry is all settled. I think these things have a tendency to overshoot a little bit on power up. So yeah, that's kind of a sensible idea actually to put that in there. Means that, you know, the output's not going to come on until the thing's actually stable, which is quite good. But I don't really need that probably, and if I did want it, I'd probably want to have something I can operate externally. So I'll probably get rid of this as well. Anyway, just to sort of bring the whole thing back to factory, and then we can just see, you know, if it actually works. See how it's performing, because again, like I said, the guy was a creep, and I have no idea whether to believe him or not about whether the thing even works. Apparently it does, but who really knows? I suppose I'll just start disassembling this and at least get rid of this cord, and then we can see if the thing even powers up and whether it actually works at all, and I can do some checks. Obviously I'll do tests before that, you know, to make sure that the power transistors aren't shorted or anything weird. Hopefully if I can get it going and get it cleaned up, it will be quite a decent little supply. Again, the current rating is not amazing, given that the cooling is a bit weird, but you know, it's pretty nice though for what it is, and I got it fairly cheap, so yeah, a little bit of work and it should be not too bad. And yeah, fortunately, like, the other meters and everything look really nice, so you know, that should all be fine. Hopefully anyway. If not, you can replace them with digital ones. So I just did a little bit of work on this and took out all this stuff here and rewired that back into how it was supposed to be. So now I should be able to test it, although I just want to do some quick sanity checks first before I actually plug it in. So yeah, we had all these wires here. I actually had to cut this white thing in half to get it out of this cord clamp thing. This wouldn't come out very easily. I had to wrench it out. That's why it's all kind of chewed up now, but oh well. So yeah, we can get rid of all that extraneous mains wiring stuff. This extra ground wire that also weren't really necessary. And we got this relay circuit thing here, which again, you know, not entirely sure if this actually worked. I wasn't about to bother testing it. I'm actually glad I removed it, because the terminal here, which was connected to the output, corroded and not very nice. So yeah, that probably wasn't making a good connection anyway, so I'm glad I took that out. So we don't need that really for testing it anyway. There are still some other issues. If you see down here by the main switch, there should actually be heat shrink on all those connectors, and there is remnants of heat shrink on there if you look close enough. But yeah, that's all been taken off. I don't know why, because all the wiring that was changed was actually down the end here, and this terminal block and stuff, which I don't know if that's factory or not, but there's this little shielding thing, and these have different variants depending on what country they're in, so this might have been for the Dick Smith version, I don't know, but this should have heat shrink on it, so I'll have to put heat shrink back on these, because that's not very good. That's exposed mains wiring to the primary of the transformer and the incoming line, so I'm going to have to take that off and put heat shrink on that as well, but again that's for checking later after we actually get the thing going and prove that it works. So actually I've unplugged the bridge rectifier to test it, because again I want to test that to make sure it's not shorted or something silly, you never know. And I can try to test the transistors as well. See, so the other thing, the silly thing with this, part of the silly cooling with this, is if you have a look at the side of the fan, the rotational and airflow indicators are pointing that way for rotation and airflow is in. So basically, yeah, this thing is sucking air in the back and basically just blowing it straight onto the transformer and nothing else really. It doesn't really cool the heat sinks very well. They basically only cool by convection out the top of the case, so there's some things there, and that's not going to blow on them very well at all. And the transistors down the bottom are all going to overheat really well because there's basically no airflow, so it's much better if you put the fan around the other way, apparently, and possibly even drill some holes in the chassis under the heatsink so air can come up underneath as well, and maybe even block the ones at the top so that the air has to come up through the bottom and go through the heat sinks. Apparently that's what one can do. Probably at least switch the fan around the other way, because blowing in like this is kind of stupid. It also explains why everything's covered in rust, because it's probably been blowing in damp air or something onto everything, which is wonderful. So yeah, we got the bridge rectifier in there. It's meant to be like 50 amps, but I don't know if that's true. The Dick Smith brochure does say that it's 50 amps. It does look pretty beefy, but whether that's correct or not, I don't know. I mean, compared to my finger there, it is quite large. So let's test across the AC plug and see if we have anything that doesn't look good. Okay, that's nothing, but that makes sense because I think the switch is off. So if we turn the switch on and measure again, we get 8 ohms, which is probably correct for such a big transformer like this. We can check from ground to chassis, make sure that's working. That's a higher resistance. Oh yeah, no, our earth is actually worse than the primary circuit, primary winding of the transformer, which is hilarious. Right, so let's go diode mode and test the no, it's continuity, sorry, diode mode here. Let's test the bridge rectifier to see if that makes any sense. Okay, 472 there. 472 there, that looks good. You got 470 there. Oh yeah, and like 400 there. Let's check across the AC pins. We get a short, but that's because the resistance of the transformer is going to be so low that you can't really test it. And we should, if we go this way, sorry, no, this way, should get like a 1 volt drop across the two diodes from positive to negative. Yep, so that looks good. So the bridge rectifier seems fine. So that's not shorted or anything. Now let's check the capacitor. I'm going to check voltages, just see if there's anything on it. Nope, it's completely zero, which makes sense. Let's see if it's let's see if it has any sort of, yeah, we got a reading and it starts charging up. So the capacitor is not shorted or anything. Obviously that doesn't tell us leakage current or anything, but let's do an ESR test on it and see if that shows us anything useful. So that's my ESR meter. Let's see if that does anything. Okay, we're getting like 0.03 ohms, so that's pretty good. You wouldn't expect it to be very high. So okay, so that should be, that doesn't look bad. Right, so yeah, there's no short across that, there's no short across the bridge, so that's a good start. The primary winding doesn't appear to be shorted. We can't really measure the secondary because, again, it's a huge transformer. It's going to have a very low DC resistance on both primary and secondary anyway. Let's see what else to test. I guess I can try to test the transistors. If we measure diode mode from, I think, from the positive of the capacitor to here, yeah, we get a diode drop. So that's good, I think. That means it's not shorted. Yeah, so this is the schematic here. Basically it there. So we've got the transistors, 5 of them in parallel there. So if I measure from the positive of that filter cap, from over here to like this emitter resistor there, yeah, we shouldn't see a short circuit there. Either way, there's nothing that I believe is anything so terrible about this that it would be an issue to plug it in. So at this point I think we can, in fact, we can plug it in and see what happens. Although I will need to reconnect the bridge rectifier before I do that, otherwise nothing will happen. So I've got the thing plugged in. Well, I haven't got it plugged in, this is plug here, but I've got the multimeter set up with volts DC. We can have a look. We can plug it in and see if it explodes. So let's try that. Okay, no explosions. Switch it on. That's good. It does come up. We get a low voltage reading. And if we adjust the adjustment, we can adjust the voltage. And it goes all the way up to 15, approximately 15. So yeah, that is in fact doing what it's supposed to do. At least in terms of voltage regulation anyway. So there we go. We can adjust it from about 3 volts to about 15 volts, slightly lower than 3 and slightly higher than 15, but that's alright. Having a 10-turn pot on here would be nice actually, potentially. But yeah, I mean we can get different voltages out of it. Yeah, because trying to set this, for example, to exactly 3 volts is quite tricky. So you can overshoot. There we go, we got it almost perfect, but yeah, not ideal for a single tone thing. But again, for what this is designed for, I don't think you really need that fine of adjustment. But yes, obviously there's no load on it, so we haven't tested to see what happens if we put a load on it yet. But it does basically work and it doesn't catch on fire immediately, so that's a good start. So anyway, I'm just going to switch it off again. I just want to look at the meter here and see if it overshoots when I switch it on. I think it probably will. Keep my finger away from that exposed mains wiring. Yeah, it overshoots a little, and there's probably damped a bit by the meter movement, so you'd have to get a scope to see exactly what that was doing, but it's not too terrible. But yeah, so that's good. So it does appear to work basically. I'd have to give it a load obviously to see how well it's really working. I suppose I should actually check the binding posts here, seeing as I had to reconnect that after taking that modification off. So let's just see if that works. Yeah, so that's still that's connected. I didn't think it wasn't, but there we go. So there is some temptation to replace this with maybe a multi-turn pot or something. Or maybe have a second one that does fine adjustment, I don't know. Now the fan doesn't turn on until the heatsink reaches like 60 degrees or something anyway, so we don't know for sure if that even works. It's not spinning right now, but I wouldn't expect it to. So the next part of this adventure with this thing will be to basically take everything out of the case and start taking all the rust off and trying to fix that up. Because yeah, I just want to not have all that rust everywhere, because it'll only get worse if I don't stop it. So it's a good idea to try to do something with that. So yeah, obviously disassembling this is going to be quite involved. I won't show it, it's not very complicated. It's just undo some screws, take the heat sinks out, take the front panel off, take the transformer out, you know, all that stuff. Drill out the rivets for the fan. I'll also take the PCB off the front panel as well, and you know, have a look at the circuitry there. There's some capacitors in there for like driving the regulator and stuff, and you know, make sure those are in good condition if I need to replace those. Aside from that, I think it's good to proceed. Everything seems to be basically working. Alright, so I was just about to start taking the fan off, but I thought I might test the capacitor for voltage first, seeing as I'd be working nearby. Probably not an issue, but I thought I'd better check. And there we go. Look at that, it's still holding 22 volts, so looks like it's pretty good. There's no bleeder resistor on this at all, so yeah, it's still holding voltage pretty well. Right, so I kind of want to discharge that before I do anything with it, which is a great point to show off my capacitor discharge tool that I recently built as well. This thing here, it's another silicon chip design which I've slightly modified, and yeah, so you just plug it in, and this light will come on to indicate that it's doing something. These probes are not very good, but anyway, the light should come on, and the light will go out when it's discharged. It'll take a while because this capacitor is really big. We could test the voltage now, see how far it's gone down. Let's see, now it's at 9 volts. So yeah, that took about half the voltage off, and however long that was. So let's keep going. I bought these little tweezer probes off AliExpress to use with it, but they're not very good. I might have to try and get something better. But there you go, the LED doesn't show up very well on camera, probably because of the ring light shining directly at it. If I turn that off, it might be more obvious, yes. I don't think it'll completely discharge it. I think it takes it down to a couple of volts or something. Like 5 volts maybe. And then I've got this button on top, which is an addition that I put on myself, which is a bypass switch. Let's see, we've got 6 volts now. Yeah, so it'll go slower, obviously the lower the voltage is. It may not go down much further than that because of the cut-off voltage of the circuitry inside here. I think about 5-6 volts. And at some point it will probably go off when the MOSFET inside has stopped conducting. There's a heatsink inside with a MOSFET on it that dissipates the energy. What is it now? Yeah, still like 5.9 volts. Yeah, putting a bleeder resistor on this is probably another modification that would be clever to do. But yeah, I just want to take the fan out. So let's see. A 3mm drill bit should be big enough. It won't be that hard to get out. Or maybe it will be, because now the rivet is just spinning around. Maybe I do need a bigger drill. These things are annoying, they're just spinning round and round. Finally got the rivets off. Just drilled them out a little bit and then ripped them off with pliers. That solved that problem. Now I can pull the fan out properly. Still got the rivets stuck in it, but that doesn't really matter. Yeah, everything's nice and crusty in there. Got to continue on with the deconstruction of this, and eventually I'll be able to start working on the case, which is pretty horrible. Alright, so I'm taking this out of here. I found the easiest way was just to unbolt everything and undo the capacitor clamp here, so I could just slide out of there, so that's still actually in the case there. But everything else I unscrewed, and I set the transformer on a block of wood here, so that it wouldn't fall down and bend the case or something when I took the screws out. So that was kind of lifted up just a little bit. So the weight of all that was taken by the wood, and this was basically just hanging off the transformer, and I just had to unscrew it. And the heat sinks are actually pretty light, so I didn't worry about putting anything under those. So everything is kind of out. Took out the overload cutout at the back. That just comes out. I was able to undo these spade terminals. This is where the modification was. That's why that's cut already. But yeah, it's kind of interesting. The wiring in here from the mains here is definitely a different colour, like not a different colour, but a different shade and different thickness to the wiring in here. So yeah, it looks like that's different wiring, and the fact that the terminals up here don't have any heat shrink on them anymore. You can see remnants of heat shrink on some of the bits at the top, but I think this wiring has actually been changed at some point. So yeah, I don't know what's happened exactly there. The terminal block that was in here, I'm pretty sure was not factory, because If you look at the hole it was mounted to, you can actually see, I don't know if the camera's picking it up very well, but you can see where that's been sort of chamfered with like a countersink bit or a drill bit or something, and you can see the hole next to it to the left is perfectly square, not perfectly square, but perfectly like punched out, no beveling or anything. And all the other ones are punched like that, they're all very clean, and this is obviously where the cable gland was put in, so that's been drilled out as well. But yeah, so I think the terminal block was a custom addition as well. So I'll probably get rid of that, it's not necessary, it just creates more potential for bad contact. So I might just solder the wires on to where they originally would have gone, or maybe I'll actually take this out and strip it back and reattach it so they've got longer cable. Yeah, I think the reason why the earth was showing up as like 50 ohms or whatever it was is probably just because the earth connection here is just so rusted and crusty, so I guess, redoing that's probably a good idea anyway. Yeah, that earth nut and everything doesn't look very nice, so yeah, redoing all that and doing it properly sounds like a good idea anyway. But yeah, so I can take this capacitor clamp out. I guess it's got rivets on it, so I have to drill those out as well and replace them with bolts. But yeah, I'll need to take that out so I can clean up this case properly. There's a lot of dust and stuff, but there's also all the spots of rust everywhere. Not a huge amount, I mean nothing terrible to be honest, obviously, but I'd like to scrape it all back and put a rust converter on it and then spray paint it. So hopefully, we don't want to rust any further. I want to deal with that. Same thing with the transformer. The bottom of the core is fine. There's barely any rust there. The mounting brackets have a little bit of rust, so I'll probably pull those off and do those as well. A little bit, and then obviously, do the sides of the core where it's rusty. But yeah, we're basically just down to two things. The case needs rust treatment and the transformer does. Everything else is fine in terms of that. Gonna have to get into here for this switch and redo those connections. I don't like the fact that those mains wires are exposed there. You've got like bare connections. They should have heat shrink on them. The transistors here are marked ST Micro, made in Malaysia. They're 2N3055s. I think they're marked 99609. So I don't know if that's 1999 or 1996 or 2009. Any of those would probably be potentially correct for this power supply. Yeah, kind of strange on this one. You can see where that brown wire actually has the original heat shrink on it, I'd say, and where it's been taken off there and put back on, so I don't know. Maybe the owner was going to bypass the switch or something, have some wires coming out the front, I don't know, but then he maybe realised that it was hot glued in and it was more annoying to do than originally anticipated, so I went with the other option. I don't know, but either way, yeah, it looks like these have all been taken off and the heat shrink is lost. Here's something interesting and not very nice that I found. This is the circuit board that contains the transistor for controlling the fan. And you can see the PCB is not in very nice shape. I've actually just desoldered the wires from it and wicked all the stuff up, cleaned all the flux off and all the dust and everything. It was buried under a layer of dust. You can see how badly the solder mask has been affected by all the dust and moisture and whatever that's gone on it. It's been sort of sitting there damp, I suppose, for quite some time, and you can see this bit here is flaked off right there. The solder mask is flaked off when I was cleaning it. So yeah, this whole board doesn't look very good. It probably still has a connection between all the points, but that's not great, especially for something like the fan controller. So probably want to do some work on that, maybe just add some jumper wires to the pins on the transistor. Could even perhaps just scrape off all the solder mask and just tin the whole thing with solder as well. That's a possibility. But yeah, that's what happens when a old PCB is left with damp dust on it for a long time. It goes like that. Also interesting to note, this transistor here is marked 9622, so I think that's 22nd week of 1996. It's a tip 31C. It's got a little bit of corrosion on the tab as well, but the leads look okay, so course that was underneath where the dust wouldn't go, so yeah, all the damage is mostly on the top there. But that's interesting because I guess that matches up with the date code on these, which is 96 as well. Well, there is a 96 on there somewhere, so I'm guessing that most of the parts from this were from 1996, so whether this was built in 96 or not, I don't know. Could have been built in 99. The schematic shows a copyright of 99, so maybe these were just components they had, you know, already in stock that they just used and in 99, or maybe this is genuinely from 96, which is pretty interesting. I mean, that would make it 96 would make it like 29 years old, wouldn't it? Probably. So this thing, yeah, this thing could be pretty old, and I guess it's held up pretty well considering how old it is. But yeah, I think I definitely want to go through the control board and take a look at all the caps on there and maybe just replace them all outright, because they are going to be pretty old, I guess, if they're like 30 years old. Going with date codes, they could be about that old. So yeah, probably worth, you know, while I've got the whole thing to bits, I might as well just go in there and replace everything. I might also redo all the thermal paste on the transistors, for example, you know, stuff like that. Possible that's the kind of thing that needs doing, and you know, you got to take the whole thing out to get at them, because they're all mounted underneath and they've got, you know, the way they're done, so might be worth doing that. Just check around. I desoldered the switch wiring. You can see all the bits of heat shrink still stuck on there. So yeah, this seems like the genuine original wiring that has the original heat shrink on it. So, but also I managed to get the cord out of the case. This little clamp actually came out really easily. Not super easily, but you know, easily enough. So I think I'm going to cut this back to about here, because like I said, there was a pretty sharp bend in the wire, like here, when it was kind of stuffed in the box or something, and who knows if it's actually been like that for a while. And considering that these are a bit short and a bit bent and stuff, I think I'm just going to cut this back and redo the whole thing and put it back in the case when I'm finished repainting that. Currently got rust converter on it. Definitely have to look into dealing with this, because we don't want this failing, you know. I also want to modify this so that the fan runs like most of the time as well, to change the settings of that. Normally it only turns on when the heatsink hits like 60 degrees or 80 degrees or something ridiculous, so we want to have it, you know, running at a lower temperature than that. But yeah, interesting. It does look like this thing is either from 1996 or is built with parts from mostly then. I also noticed another thing with this. On the front panel here, there's actually a crack. There's a slight crack, and this foot here is kind of cracking off there, but I don't think there's much I can do about that, and I don't think it really matters, because once that's screwed onto the case, it's not going to go anywhere, so I probably won't do anything about that. I could put some epoxy in it, but I don't think there's any point. Alright, so I've continued disassembling this, and finally have the transformers separated, so I can go and work on that, and try and get rid of this rust and treat that and solve that problem. I had to take the bridge rectifier off the heatsink because these wires were soldered on. It was very difficult to heat them up. I think, you know, and being on the heatsink is not going to help, so I thought I'd just take it off, and then I could check the thermal paste and redo that anyway. But annoyingly, the wiring coming from the capacitor to the inputs of all the transistors was routed between the two output legs of the transformer there, so I couldn't actually take that off until I undid all these from the terminals on the transistors, and then I could pull it out through here. So yeah, I don't know if that was originally done like that, or if that was done separately, done later on, I'm not sure. But yeah, I think these might supposed to have spade terminals on them, and they can just unplug, which would have been a lot easier, but perhaps the previous owner actually soldered these on, I don't know. I guess I might as well just leave it on there, because yeah, there's not really any reason to take it off at this point. The bridge rectifier appears to be fine. I can always test it again when now it's fully disconnected from circuit, but I'm pretty sure like it's working. We powered it up and it didn't explode, so I think it's okay. I think this one is actually the 50 amp type, but as I was reading, about the whole thing, the cooling is not very good, so it can only really do like 15 amps continuous maximum, really, I believe. These two leads here are for the control board power, so it's like an auxiliary winding on the transformer. This is the main output. And then we just have the two wires for the primary. So yeah, that's all separate now. I can do the rust treatment on that. Some of it's pretty bad. Well, not really bad, but we definitely have a pretty crusty look over here. You can see there's quite a bit of rust there. I mean, again, it's mostly just surface rust. It's no big deal. It would take a long time for this to get to a point where the transformer was actually damaged and unusable. It's very minor, but I'd like to, scrape off as much as I can and treat it so it doesn't get any worse. But yeah, so hopefully that'll solve that problem. And yeah, then I've just got to look at the transistors, I guess, the heat sinks. I might as well clean those up. They're all quite dusty, so I guess I'll take all the transistors off and everything, and then I can redo the thermal paste anyway. Oh yeah, I guess, well, yeah, the transformer PCB, the capacitor PCB also has all this corrosion on it as well. So I might have to do something about that, which is annoying. And yeah, we also have the same kind of problem in various places on the control board PCB as well. I also wondered if these components here were from some kind of a modification that was done. But I've seen videos on YouTube of someone repairing a similar power supply, and these components were there as well, so I think that's a factory mod. What did surprise me and was not very good was how the terminal that screws onto here and this point here, there was about 2mm clearance between the main negative terminal and this point here, so it would have been nice if they'd put some insulation over that bit. I think I'll add some heat shrink to it or something to avoid that being too close to this. They've got a little piece of foam to sort of insulate it from the board, but yeah, it would be nice to have put some extra there. But yeah, we do have this issue where we do have corrosion sort of starting. Well, the solder mask is sort of bad. You can see traces like here. You see that dark sort of colouring, and like up here, like right there. So there's various places, and then here it's kind of quite obvious on these two tracks there, and down here on the main sort of thing, and even there. So that's it obviously it still works at this point, but that's going to get worse over time. So I think I'm going to have to scrape all that off. Where that is, it's not much, it's only in a few various little places, but obviously if I scrape all that off and tin it or something with solder to make sure that it doesn't get worse, because that's obviously a problem. Again, this thing is probably like 30 years old. Pretty much everything I find in this has a date code of has either 95 or 96 on it. That capacitor there says 95 on it, so I'm pretty sure this is from like 1996. So yeah, I'm going to have to take this board off as well out of the front panel and check all the electrolytics. There are some on the other side, obviously, not just that one, which I think is a bipolar one actually. It's marked ND instead of a negative, so I think that's just an old style way of marking a bipolar one, or non-polarized. I think the circuit, the schematic even shows that as being that. So yeah, 15 microfarad, 35 volts, ND, I don't know, because most of them say NP for non-polarized, but anyway, to get this board off the front you have to desolder the meter terminals and obviously unbolt the binding posts so you can take it off. So yeah, I guess I'll just keep disassembling this thing. So I had to take the transistors off the heatsink to clean it properly, and I thought I might as well redo the thermal paste anyway, but that's annoying because the insulating washer that goes here is obviously trapped by the heat shrink on the wires, so I'm going to have to take the wires off as well to get the thermal paste all cleaned off and put new stuff on and all that. But I guess it's probably worth it, after 30 years I think it deserves to have a refresh. The other amusing thing is that the thermal switch for the fan control had no thermal paste on it whatsoever, so That seems a bit silly. Not that it probably needed it, but I guess when I put it back on I'll give it some anyway. So yeah, not an insignificant amount of work to muck around with these things, but you know, I think it's worth it in the end. This thing's not too bad. Alright, so I've got the thing pretty much torn down to its component parts. Everything's, all the transistors are off. Front panel is off the front. I've taken the heat sinks and cleaned them, got all the dust and grime off. So yeah, I can put all that back together soon. I've just got the transformer in the case. Currently in the process of rust treatment and repainting, so I can't really show that here because I'd get wet paint and stuff everywhere. There's the heatsink mounting brackets. I didn't do anything with those because they weren't too bad. I've got some mains wiring that goes to the switch, and everything else I've just got in this little storage case here. For when I put it back together, I just want to keep all the screws, you know, with each of the thing that the screws go to. I won't reuse all of the screws probably because some of them are pretty rusty and are bad, so I might replace some of those. But yeah, I mean, everything's sort of the only thing I really need to do is, like I said, do the corrosion treatment on this, clean up the traces that are starting to corrode. But the next thing I need to do is get the washers off these transistors, and that means getting the wires off because I can't get the washers off to reapply the thermal paste because the wires are in the way. So I'm going to have to take those off. But I tested all of them, they still test perfectly fine. At least in diode mode anyway. I haven't actually tested the gain or anything, but I don't see why they wouldn't be okay. And it is interesting, they all seem to be the originals. They've got the date code, which I believe is 96, 5th week of 96. So yeah, I think these things are all original, they're all pretty old, and interesting enough, they all still seem to be working fine. I thought maybe one of them might be open circuit, but no, they all seem to be alright. So yeah, I guess this thing was kind of looked after in a sense, even if it was rusty, it wasn't overheated or anything. So yeah, these transistors are like 30 years old and they still work. So yeah, I need to take those off, and I suppose the easiest way potentially to do that would be with a scalpel, to cut the heat shrink so that I can get that off, I'd say. Just sort of slice it a bit, and then I should be able to pull it off with pliers or something, because I don't want to snap the micro insulator. I don't want to damage the pins of the transistor, but the only way to do this is to take this off, so I definitely have to remove them. In fact, I may not have needed to go all the way. I could have probably just done the top bit and then desolder it and then pull the rest of the heat shrink off. So let's just try that. Should have had my soldering iron on. Anyway, I mean, I do have more mica washers if I broke these, but you know, I'd rather reuse the originals. I don't want to have to replace them if I don't need to. There we go. I think I've exposed the wires enough. Yeah, there we go. So that's those two off there, and now I think I should be able to pull the heat shrink off the leads. Yep, there we go. Excellent, and then I can take the washer off. Oh no, there's a little bit of solder still on there. First of all, I have to clean up the solder. And then the washer comes off, and there we go. So all this paste is quite dry. I don't know how madly that will affect the performance of it, but I do know for like CPUs and stuff that it can dry out and become less conductive, and temperatures can go up, and you know, reapplying it can bring things back to normal. So I wouldn't be surprised if this stuff is not optimally functioning at this point, given how old it is. Replacing these will probably be a good idea. So I just got to take all these off, clean them all up, reapply the paste, and I think I'll mount the transistors back on the heatsink, and then reconnect the wires and then reheat shrink them. In that case, I think that'll be the easier way to do that. But there we go, that's how you do that, if you were wondering. Highly recommend a very sharp blade like a scalpel, works very well. Yeah, of course if you don't care about the washer you can just break it off and then use other methods to get the heat shrink and stuff off, but I figure, you know, why replace something if you don't need to. And yeah, I guess maybe I will re-epoxy this thing here. You can see this crack maybe kind of there. Yeah, that sort of cracked a bit. So I might put some epoxy on that. I doesn't really need it, but I might do it just for completeness' sake. I may replace these nuts too, because they're a bit rusty as well. I already had to put a new washer on this one because the original one was lost, thanks to the modification that was done on it. But this other one on the negative terminal seemed to be fine. There's a couple of screws here to hold the board on. Yeah, so take the two screws out for the sort of spring terminal thingies. Okay, so the board should be free except for the meter terminals, which are soldered there, so I just need to desolder those. I know I'm spraying bits of solder everywhere, but I can clean that up later. It's fine. Those all free. Yep, those all look free, so this board should just come out now, I believe. Oh, I forgot to take the knob off. And there we go, it just comes straight off. It's just the 2 meters just screwed in there, so you do have to take the board out to get the meters. If you were replacing the meters, for example, you do have to take the board out, desolder them. I mean, you can't just unscrew the top. You can see these 2 screws from the top, and you could theoretically unscrew them without taking the board out, but you need to do that to actually get them fully out of there. So yeah, so there we go. That's how you do that. And yeah, I mean, it just looks like standard meters. I guess, you know, if the meter failed, you could probably just buy a new one and transplant the dial backing, or whatever you call it. I'm sure there's a name for that for some reason I can't think of. Yeah, you could just probably replace the meter and then replace that. You'd have to obviously make sure the meter was the right type with the correct FSD value for full scale deflection. I don't know, it doesn't say anywhere on there what it is. Maybe it's buried under here at the front, so I can just put that aside. And yeah, we can have a look at this, I guess. Pretty simple. Looks how I'd expect. We actually got some pretty nice capacitors there, Elna brand, so they might actually still be good. So yeah, the date code, like on the LM723, is, I mean, again, we got like W992A9644. So yeah, I mean, 92 or 96, I don't know. Also probably 99, not sure. He'd have to get the data sheet to read that. And then this, what is it? I think it's a dual op amp, or quad op amp, or quad comparator, or whatever. The 339. That's got 9415 on it. So yeah, and I mean, this cap on the back here says, I think, 9502 there. The transistors appear to say 96, so I'd say this power supply could well have been built in the mid-90s. It certainly has that look about it. But there we go. That's the well, teardown, I guess, currently of the Dick Smith D-3800, also known as the Manson EP925, and I don't know what this code here is, EP91100. Maybe that's the board code. I don't know if that's a PSU code. This is probably used in various designs, I think, depending on what power level you want and all that sort of thing. So that's it for that one. Not much else to say at this point. I guess I'll come back and make another video when I go to reassemble it, and talk about that perhaps, or whatever. But for now I think this is good enough. So yeah, see you next time.